Lecture 15 covers sections 5.2 through 5.3. At the end of today's lecture, you should be able to transform voltage and current sources to current and voltage sources, respectively, using source transformations. You should also be able to apply the superposition principle to circuits such that we can analyze the contribution of each independent source to determine the ultimate behavior of our circuit. To begin, we will discuss ideal and non-ideal sources. Thus far, we have considered our sources to be ideal. That is, regardless of the load resistance our circuit places on our source, we'd expect the same voltage potential or current to be drawn. In reality, our independent sources exhibit a decrease in voltage or current as power drawn is increased through our circuit, i.e. as our load resistance changes. We could represent this as a voltage versus current graph. Ideally, we'd assume our voltage would remain independent of our load resistance. In actuality, once we begin to draw too much current, our voltage is going to taper off. To model this behavior, we can place a resistor, R sub S, in series with our voltage source, V sub S. That is, as we draw more current, we will begin to have a voltage potential that decreases such that when terminals A and B are connected to our circuit realizes a lesser voltage potential existing across it. Or we can replace our ideal current source with a current source that has a resistor, R sub P, in parallel with said current source, I sub S. That is, as we connect this non-ideal source to our circuit, R sub P will draw some current off, resulting in a lesser voltage potential and lesser current supplied to our circuit. Now, under some certain circumstances, our non-ideal voltage sources and current sources are equivalent. That is, we can say if we have a voltage source V sub S connected in series to a resistor R sub S that's connected to a circuit via terminals A and B, our circuit would have some particular behavior. Now, if we transformed our voltage source to a current source and R sub S to R sub P, and then connected this to our circuit at terminals A and B, our circuit would not notice any change of our current source or voltage source applied. That is, we'd have the identical behavior of our circuit, such that when a source transformation occurs, our circuit behaves exactly the same. That is to say, we could have a voltage source or a current source supplying our circuit, and it would not know the difference.